So again, my name is Jake Marcinko, Standards Manager for the PCI Security Standards Council, and I'm here today to talk about bombs. Not these kinds of bombs, but these kinds of bombs. Before I get into this, is there anyone here who does not know what a software bill of materials is? All right, good. We can skip over some of that a little bit. So again, we're talking about bombs today. For those of you, in terms of talking about software bill of materials, a lot of the talk about software bill of materials really originated in the U.S. with the release of the Executive Order 1428 in 2021 as a response to the SolarWinds attack that compromised a lot of government systems. The executive order actually includes a clause that requires all software vendors who provide products to the government or to the U.S. government to provide a software bill of materials for any products that they sell. Now, this was one of the first times, at least in the U.S., that the concept of bombs was actually acknowledged in U.S. legislation. However, the concept of a bomb has actually been around, or software bill of materials, has actually been around since about 2010 when the SPDX specification was released. And there are other entities that are looking to adopt the same concept, including the EU Cyber Resiliency Act, or CRA, that is going to be going into effect in 2027. In addition to the EO 1428, the PCI Secure Software Standard has actually required software bill of materials since 2023 for all web-based software. And for those of you who do participate in the software security program, we are looking to make that a requirement for all software moving forward at the next release. So now it's just mandatory for web-based software. We're looking to make that mandatory for anyone who participates in the PCI Secure Software Program. Now, in terms of bombs, and I'm going to talk about bombs more generically, there are really two predominant specifications. There's the System Package Data Exchange, or SPDX specification, and that's the one that's been around the longest, since 2010. And that's maintained by the Linux Foundation now. And then there's Cyclone DX, which is the counterpart. That's a little bit newer, and that's maintained by the OWASP community. Now, there is a third specification. It's called the Software Identification, or SWID. That has been around a while as well. But that one's not really used quite as extensively anymore. However, there are elements of it in it, and SWID tags, which is a way of identifying software, are supported by both the SPDX and Cyclone DX specifications. Now, for our discussion today, I'm going to focus explicitly on Cyclone DX specification because a lot of its extensibility, not just within software bill of materials, but in other potential use cases. So, if you're not really familiar with bombs and you're wondering how to create a software bill of materials or bill of materials, there are an increasing number of open source and proprietary tools available. I'm sure you can find at least a half a dozen vendors in that vendor showcase right now who have a product that can help you with this. But despite the increased automation and availability of these solutions, there are still some elements of a bill of materials that might need to be manually generated. I think I talked to a couple of vendors in the vendor showcase earlier, and why they can help you create a software bill of materials in terms of open source components. Not all of them are able to do that with proprietary or home-built components. So in some cases, you may need to still manually document those types of components. However, this is an area that's growing rapidly. There are increasingly more automated solutions available, so I would expect this space to continue to grow rapidly. Now, again, I started talking about software bill of materials, and then you heard me speak more generically about BOMs, or bill of materials. And that's because there are so many other use cases for this type of technology beyond just talking about what is contained within software. So the Cyclone, this is a graphic provided by the Cyclone DX, and it supports a number of different types of bills of materials. We've already mentioned software bill of materials that describe an inventory of software components for a given piece of software, as well as any transitive relationships that those components may have. But Cyclone DX also supports what's called a SAS BOM, and this is a little bit different than a software bill of materials because if you're talking about embedded software, all of the libraries and components are self-contained. Whereas when you're talking about a SAS BOM, now you're bringing in the concept of services, and those services might actually be external to the software running. So you have a SAS BOM that can describe those types of components, such as inventory of services, endpoints. It could also describe data flows. It could also do data classifications. This is something that we're looking heavily at within the Secure Software program. And for hardware vendors, there is an HBOM, a hardware bill of materials, and this can help describe the components for like IoT devices, integrated circuits, and any other types of embedded devices. There is an ML BOM, a machine learning BOM. And now this can describe an inventory of all the machine learning models and data sets that might be used to provide visibility into possible security, privacy, safety, and other ethical considerations. And for those that were in this room for the cryptography talk, there is actually a CBOM, a cryptography bill of materials that can describe an inventory of cryptographic assets and the dependencies among them. So all of these different types of BOMs, depending upon the complexity of your solution, they can be combined to create a full stack inventory of everything contained within a solution or a service. Runtime environments, configurations, cryptographic assets, any additional dependencies for a given implementation. And this is achieved through the deep linking capabilities within the Cyclone DX specification. A BOM or a bill of materials could be completely self-contained, so everything that within a solution can be described in a single document, or it can be broken out into multiple different documents and then referenced each other. And this is really good if you have a solution where you have aspects of a solution that change rapidly, so the bill of materials for that solution changes frequently, but then you have other components of that same solution that maybe don't change that often. And so it's ideal to be able to split this out and still be able to reference an entire bill of materials, but that way you're not trying to manage this all within one document that might need to be, if it is in one document, depending upon how often you're doing releases or patching components, you might be constantly updating this document. But with the ability to split these out into different documents, you can manage those documents separately. So we've talked about bill of materials, but and how it describes an inventory of the components within a given solution. But this isn't everything that Cyclone DX can be used for, and there are two particular use cases that we are looking at heavily within the Secure Software program. And that's these two capabilities, the standards and attestation capability of Cyclone DX. So the standards capability, within the same specification, it allows you to describe a set of requirements. And I've got some graphics here that we'll show. So this is a prototype of the current published version of Secure SLC, so version 1.1 in JSON format. And you can see if you look down to the, well, you see the standards. So under the standards tag, you can see where the requirements are specified. So there's a parent requirement and some nested requirements. And so that's something that's really cool with this specification. Not only can you do that, but it supports requirement nesting. And for those of you who had dealt with the council for a while, you know that we like to nest requirements within other requirements. And there are numerous benefits for being able to articulate our standards in a machine-readable format. First of all, it simplifies updates to GRC systems when a new version of the standard is launched. It also enables organizations to conduct a more detailed analysis of what's changed from version to version. This would be adding on to the summary of changes documents that we typically do. But because the standards are published in PDF or Word format, it's kind of hard sometimes, and we don't provide redline versions, although you guys have asked for that for years, and we seem to have resisted that. This would give you an ability to be able to do a diff on 2 different documents and see exactly what's changed from version to version. It also allows organizations, for whatever reason, to display the requirements in whatever format that they want. It gets the council out of the formatting game. And lastly, and this is a bit selfish, it also eliminates duplication errors across PCI documents. So for those of you who have seen a ROC, those are separate documents, and a lot of times when we create those documents, we basically do a cut and paste from the standard into those documents. But sometimes there's cut and paste errors that happen, so we do have instances where there's some discrepancies between the standard and the reporting template, even though that those documents should look almost identical. The other capability that's of real interest to us is the attestations capability. And what this does is that within that same bill of materials, so we've identified the requirements, it actually allows an assessor to assert, or an assessor or even an entity that's being assessed, to make assertions about their ability to comply with a given requirement. So here's a full snippet, and we're going to break this down a little bit here. So here's a full snippet of code that we'll look at. The next slide, this code's going to slide to the right, and then we're going to zero in on certain elements. So the first part of the document at the top, so what we were just looking at's on the right. In the center of the screen, you see the schema tag. That identifies the schema or the format that we're going to use for this specification. The next part provides some metadata about the document itself. You have obviously the BOM format, which is CycloneDX. You have the version of the specification that we're using in this instance, which is 1.6. And then the serial number is actually a unique identifier for each bill of materials. And this is important. This is a best practice for bill of materials. You want to make sure that you can uniquely identify each BOM. Now, that doesn't necessarily mean that you're going to have a unique BOM for each software version, but this is a way to differentiate different BOMs, and I think it's actually a mandatory element of the CycloneDX specification. The version of the BOM, so this is just an identifier. You can do version management on your BOMs in addition to the serial number. And then here's really what I'm wanting to zero in on, is this bit about the declarations. So this is really a mapping. So what it does is it identifies the assessor. So in this case, it's just a generic company called Assessor 1. And then underneath it, there's a little bit more information. And this will actually map to a different section, which we'll look at here in a minute. So the attestation is really where the assessor would specify their findings. Again, you have the reference to the assessor company themselves. And then through the BOM reference, that's where you would reference where the detail information for the assessor is. Then you have the, this is the reference to the assessor section. And then we zoom in on the requirement. So here's the requirement. You have the requirement, and this is just a generic requirement 1. And then next to the claims tag, this is just a reference again. It's a reference to an actual claim that's made. But this is where the entity or the assessor would state their assertion about whether or not that they've met the requirement. Let's see if we got a little graphic here. And just to zoom in on, so this is the reference to the actual claim. The target is Acme Inc. You got the statement here. And then you have a mitigation strategy, which is what the control is or what the entity is doing. And then you have, it also allows you to specify the evidence to support the claim. And here's the evidence. So here's the reference to the evidence, the property name, the description, the name of the data, and evidence here is where you would specify that. It also allows an assessor, so if you have an assessor doing a third-party assessment, it allows the entity to make a claim, but then it also allows the assessor to make a counterclaim. So if there's a discrepancy in what the entity, what they've made is in terms of their assertion, if that differs in what the assessor has identified, that can be specified in this document as well. It also allows the assessor to provide a conformance score. Now, the conformance score here, I think, is it a 1? I can't really see that. But the 1, it would effectively mean 100% conformance. So they completely met the objective. If it isn't 100% conformance, it might be like 0.8, so 80% conformance. But it allows the assessor to specify a conformance score. Also allows the assessor to provide a confidence score. Same sort of scaling on that, as well as provide the assessor's rationale for the score. And then lastly, it allows the assessor to cryptographically sign their assertion on a requirement by requirement basis. Okay, we talked to the counter evidence. I forgot there was animations here. All right, so what are the benefits of doing machine-readable attestations? Well, there are many benefits to the potential of using electronic attestations. They would eliminate or at least minimize the need to maintain these documents in Word or PDF format. Now, I don't think we would get away from providing PDF or Word versions of our standards, but a machine-readable version, we might make that available in addition to our standard formats. Again, and it also allows an organization, for those how many folks here are assessor companies who submit ROCs to the council? How many times have you asked to be able to customize those ROCs? So, yeah, I see some of you laughing back there because you've probably been asking for that for years. And while we do allow some customization, the way that the documents are forwarded, they can be a challenge to work with sometimes. This would eliminate that need. So we could provide a ROV that would allow you to state your claims, and you could give that back to us in a machine-readable format, and then you could take that document and then convert that to whatever format you wanted to do for your purposes, while still supporting the council's purposes. Excuse me. Oh, can we go back one slide? Sorry, there was one thing I missed. Thank you. It also allows information within this document to be updated or appended as needed. So no more red line ROVs whenever we do a Delta review, for example. And there are other benefits as well, but these are really the chief benefits that we see, or what the aspects of this that are most interesting to at least me and those of us working in the secure software program. There are, however, some challenges. First and foremost, in order to take a standard and put it in a machine-readable format, it really has to be written in a way to support that. And right now, a lot of PCI SSC standards aren't written in a format that would be conducive to putting it in a machine-readable format. For instance, requirements where we have a bunch of bullets in there, and there we have many standards that do this. That is not conducive to a machine-readable format. So we would need, we would need to write our standards in a way to be able to support this. Oh, sorry, I did not mean to advance that. The other thing is that even though I've talked about Cyclone DX, the council has not standardized on a schema for this. Now, we are going to pilot this within Secure Software for the next release, but there are no other plans, at least immediately, for any other PCI SSC programs to do this. Because, again, some of the standards might need to be completely rewritten in order to support machine-readable formats. So next steps. So as we continue to find an appropriate schema or solution, we ask that you please be patient. I know there's a lot of demand for this. Andrew's already talked about it a little bit this week. It's not something that's going to happen rapidly. Again, we are going to try and do a pilot for Secure Software and Secure SLC when we provide a publication sometime next year. So that's going to be our first foray into this. Depending upon how that goes, we may look at duplicating that effort, or we may have to course correct and find another method. But if you are interested in this and you would like to see, so I mentioned we're going to do this in the Secure Software program. If you're interested in other programs maybe leveraging this technology as well, please take advantage of the RFC process. Make sure that you provide your comments on, we'd like to see machine-readable versions. Leverage that. I think Andrew said this earlier. We cannot function without your feedback, so we need your feedback in order to make sure we're focused on the right things. And again, one more time, keep in mind that in order to implement this, this does require significant updates in some cases. So again, be patient. And I think, sorry, I think that's it. Oh yeah, sorry. So for more information on the Cyclone DX specification or SPDX, here are the links to the website. And with that, thank you for your time.